Live streaming is on.
Hey everybody, welcome. We are here now with the GCScript PBL for developing with this with wallet scripting or wallet scripts, developing the apps or solutions. Also developing Java in general. So welcome back, guys. I am setting up here uh, my browser to share screen. Um, Gabe, do you want to, uh, you know, launch the topic of today?
Sure. Well, as I explore more and more on what Game Changer can offer, I'm building, the minting tools in ARP Radio, and one of the things I would like to do have like a decentralized marketplace, right, where we just lock up tokens in a contract, declare beneficiaries of this sale, so we can have multiple shareholders, if you want to call it here, each with a percentage of the profits, right? And then, yeah, you just set a price, the tokens that you're locking, and then the beneficiaries. And people just pay, and, the contract basically keeps track of all of that there. So getting to a point where we can build our contracts. So I have some Plutus code. Now I am trying to develop the GC script that will prepare the proper datum to interact with this contract here. And I'm kind of new to Helios, so I'm able to compile my contract. But the question now is it GC end or is it my contract where I'm running into issues? Because when I try to fill this contract, I get like a null message alert modal, and I'm not sure where I'm stuck here. But yeah, essentially, how are we supposed to properly integrate contracts within GCScript?
Okay, great topic for today. I love it because I think we never discussed this properly on any live coding session. And this new release has some bug fixing and some optimizations that, especially around minting, for example, with Bluetooth, that will ease some stuff there. But yeah, let's jump into it. Do you want me to share screen or do you want to share screen? I was preparing something, but depending on you, I can maybe
I'm in
show
learning
you
mode at this
quickly
point.
how I. What? Sorry.
I'm sorry. Yeah, the lag. I was saying I'm in learning mode, so I am very prepared to see what you have to show.
Okay. And I'm not an expert exactly on smart contracts, on validators on Cardano. So yeah, especially on Ilias, I manage a bit Ilias, but I'm not. So the nice thing, at least I can help you with the off chain, with the transaction building. That's the good thing. I'm still learning. Like we'll focus more on the times to come on validators. Okay, let me see. Let me prepare a bit here. So, okay. Are you watching?
Yes, sorry.
Okay. So, um, we'll collapse this. So, for example, well, are you going to be dealing with any sort of minting for any kind of beacon asset or anything like that, or you're just going to be dealing with outputs and inputs on your validator? What's the
So the
because
idea here is we would already provide the minting tools for the person to create their music token. So the assumption is that you've already created your supply, and now you're locking them into this contract. So initially I was building a front end that would essentially have form inputs for the token ID, asset, or the policy ID, the asset name, the token price. It assumes you're one of the benefactors, but you can assign yourself a 0% and then add any other benefactor on top of that. And from there, the front end would generate the datum from those fields and then, generate that GC script. The assumption was that you already had a token that you're locking up. So the datum wants the policy ID, asset name, the token price, and then the public key hashes of all the benefactors.
okay, so probably this example, we have two examples now around Ilios. We have like a time lock example where you deposit, you make a deposit of assets on a smart contract based or Bluetooth based address, and then you depending on who you are and the time where you're trying to to withdraw, that will work. And the other one is for minting, but yeah, just mentioning. So let's analyze this one. But let me check, because you need to pass a datum, so I need to remember if yes, we have a datum here as an example. Let me see. Let me double check. Okay, but the thing is that here the datum is provided within the output. Yes, here. Actually, let me see, datum X. Yes. Yeah. Okay, so as you know, there are several ways to deal with this. I mean, it's a very open system where you can use datums, like you can consume the datum entirely. You can even deal with the hash of the datum. You can pass like a hash. That's how Bluetooth worked on the early ages. Then this thing of inlining full datums on output was a thing, and for example, here we are using that. For those who don't know what a datum is, just imagine a piece of data that you're passing to these smart contracts, these validators on Cardano. You can pass it through an output and then reference or consume that output, or you can also deal with that directly on the transaction where you're executing on this validator, this smart contract. So in this case, Gabe, is this useful for you, like having the datum on an output, or you should be providing the datum, you know, on the transaction itself, where you are going to be applying this validator?
I mean, at this point, I can see just any example, right? So I'm not sure if my approach is even, maybe I'll adapt my approach.
Okay. For swapping, for doing stuff like swapping or other variations on 2 or 3 protocols, let's say, there are these guys, Fallen Icarus, Rusty, who is creating a set of protocols that are very aligned with our approaches regarding decentralization and a lot of other Web3 values. So keep them in mind. I don't know if you have been reading that, but keep that in mind. Of course, it's not Helios, but keep that in mind because maybe that can be useful, and a lot of people is putting eyes on that code. So also will help because it's quite it has a lot of feedback. Just that. But okay, let's go. Let's make a walkthrough quickly on the code. Okay. For let's start with things that has to do with the smart contract itself. Well, first, every time you you create a Bluetooth-based address, you can create like an enterprise address without staking credentials, or you can put a staking credential. Here, we are opting that option, like using a staking credential. Here, it's hard-coded, but you could be using your own as a DApp developer, your own staking credential, or you can let the user to inject on the code automatically their own staking credentials. Here, this is similar to what you need. You need to deal with beneficiaries, owners, whatever, these kind of roles that are based on most likely on the key hashes of the users. In this case, we are using it's a mix. I remember now that this has a requirement that this example for making it easier, it needs another type of wallet. I don't know if I have funds on mobile. Let's try. Otherwise, I will have to import another wallet. But yeah, basically, because it runs, it's an example. It runs here on this device. I'm using like the spending keys as the beneficiary and the staking keys as the owner pool, just to avoid switching wallets for testing. But of course, this can and should be modified. Then yes, it has a time slot because this deals with time validation. Whatever. So this is the important part. So datum. For constructing datums and redeemers, which are basically the same kind of underlying data structures, you use this Bluetooth data function. I think there was another way of passing Bluetooth data. I think you can pass, if we check on the documentation, we can pass also CBOR or other, even a JSON, like a normal JSON. And the function will try to serialize it as data. But the thing is that the formatting of datums, as many CBOR-based structures on Cardano, are sensitive to the tooling that creates it. Okay? It's not like there is a very strong standard on how you should do it. So it's not so trivial to just have a JSON structure and convert it into a datum. It depends on the tooling. There is, of course, maybe with Aiken, there is like a more popularized version now of how to do this stuff. But the nice thing to have is freedom of choice. So in this case, you can define your own structure, because this JSON that you're looking here on this object property is basically defining how the CBOR will be serialized. Okay, and it's typed. It's based on types, which is good. So you say integer, for example, in this case, this is a list. And here you say integer and you pass a number or bytes, and this is a byte stream. Okay, so that's how it works. And this is, you will see this definition of datum matches the code, the alias code and how the alias code, you will be checking here how alias, an alias structure can be represented on datum here, which is, is one of the nice things of this example. Let me go quickly, and then we will analyze the code, the alias code, and maybe run this. Then you have this Bluetooth script function, which you can pass a UPLC, pre-compiled Bluetooth script on any language, like Bluetooth itself, or Icon, Ilios also. Or you can pass Ilios source code, which is the case. The good thing about passing Ilios source code is that you can parameterize that code. So I'm just throwing you options, right, Gabe, for you to use. Why is important? Because remember, if you don't change the code of a Bluetooth validator, if you don't change the code, you will always have the same script hash. That compiled Bluetooth will end up having a unique hash. If you change 1 byte of that code, the hash will change completely. When a Bluetooth hash changes, depending on what you are doing, but also changes a lot, like the smart contract or validator address changes completely. The policy ID of the minted assets you're minting with Bluetooth change completely, right? For just naming examples. So this is good to you to have a means of parameterizing client-side smart contracts or validators on Cardano, because you can adapt on the fly on users' wallets a smart contract based on the user point of view. On the other example, the minting one, the policy ID changes per user. So, for example, per user or per asset, not per user. But that's a good thing. If you want, you can use that. Another thing that we will be checking today is that you can, this is very cool, Ilios allows you to export, to create and export data structures from within the code itself. And you can reuse that serialized as JSON on GCScript. So what I'm saying, and in this case is kind of being used that way, is that this smart contract here creates an example datum that then we will be capturing under this name on GCScript, and then you can patch that and customize that datum to use it to interact with the smart contract itself. So it's a nice thing because this helps, getting away of these compatibility issues on how should I design this datum, how should the datum for this contract should look like. That's very powerful. It's very cool. Last thing, but important tip, simplify false will keep debugging functions on the smart contract. If you put here a true value, a value true, it will remove what is called node traces. That are traces that the execution of this contract, this validator on the node will be producing or not, depending on its failure. When it fails, it can just throw a message like an exception and a custom message that the developer can instruct. This is why it's false here. And it's important, if you change this to true, the hash will change completely as well, because you are literally removing pieces of the validator from the validator code. That's why it changes the hash. So keep that in mind. Okay, and here we create the smart contract address. We say, okay, for the address of this smart contract where we will be locking funds, for the spending permission, which is the thing we want to control through the smart contract, through the validator, for the spending permission, spending credential, we pass the script hash, right? This function outputs the script X, like in hexadecimal. That is the compiled Bluetooth validator, and the hash. Well, here we are passing the hash. And for the staking credential, as I mentioned, the hard-coded value for everything there will be, for example, automatically being delegated to Apple. Or a deep rep also. Okay, a quick stop here. How are we going? Okay, I'm talking too much. Should I go more deep?
No. I'm following it so far. It's just I guess in the case of my contract, I need to. What I guess I could try too is I don't know if I mean the fact that I compiled a contract doesn't mean that it's correct, right? It's just kind of like cool, it compiled. So I can give you a Plutus contract. I can give you what should be the example datum, and we can try to interact with this maybe on testnet. Because on this one, I seeing this now, I wasn't structuring the datum how this is, but maybe what would be more helpful is if now it's more specific. So I think I'm seeing where my error might have been. And you said it specifically where, because the front end is what is generating the datum. So it's kind of like, well, that might be my issue here, is how is this parsing happening, right? And when you said that, I was just like, man, I think this is key to like why it's not working. So it might be what I'm doing first is I have a front end application that generates the GC script. So let's rewind from that. Let's get a working GC script that will interact with my contract. So I want to verify that the contract works how I designed it. So
okay. If I may, I can share you like 2 more tips or 3 more tips prior to jumping into that. And I have some ideas of what we can be doing. But let me, because this is the first time anybody will be looking like a full walkthrough on
this is a huge benefit for everyone else. Correct.
So but come on. The idea is to help you. Of course, you are the priority. But just because we're here, also this is good for you, for keeping in mind, because sometimes you say, okay, I just want to plug the thing and let it work. And it's good to also think on the possibilities that the tooling gives you to see how you can use them, to avoid maybe doing a lot of extra work that you can just simplify here, or maybe not, I don't know. So that's a good one. Then we can jump into Inception, and then I will give the mic to Martin.
I was just saying, with Inception, you can see exactly what is going on and do it.
Sure, exactly. But let's go step by step, so we don't, overload people's minds right now. Let's go step by step. So in this case, because like Gabe is saying, most likely he will be needing to just send assets to a smart contract address, and to let that address control the spending of those funds, right? So there is a locking stage where people will be sending assets to this smart contract address. In this case, the address of the output of this transaction, of course, comes from here, right? From this function that created this address for the smart contract. Here you are embedding the datum that was built here, right? You're embedding it fully on the output by using this EISL line, right? And of course, then you have assets and whatever. And this is the important thing that I don't know, guys, if you know about this. And this is not only useful for Bluetooth, but especially useful for Bluetooth. Bluetooth validators, or Cardano in general, is very sensitive to the inter-transaction indexing of its features, of its parts. Like it matters a lot, the order, the place, the reference of each of, for example, the outputs of the transaction. Maybe you have never stumbled upon this, upon needing this, but for example, from my standpoint as a wallet builder, this is my everyday language. Like, I need to know exactly which output has which index, which certificate has which index, the same with means, everything. And for a Bluetooth validator, it's super important because it needs to, sometimes it needs to spot or rule an exact UTXO, an exact output, an exact input, right? Checking for example, if the user is paying the exact amount you are expecting to be paid, in your case, Gabe. So this is why it's very important to have, to be able to locate exactly which input, which output we are talking about. This is where GCScript introduces tagging, or I will say tagging, like tagging or marking all these transaction features. Because when you build the transaction on your own, like in the CAP30 world, you are having full control of the building of the transaction. But when you're delegating this to the wallet side, which is this very different approach we are always dealing here, there are a lot of other challenges. And one of these challenges is to delegate the transaction building, but without delegating full control. Like, you need, as a developer, to give orders to the wallet and to know exactly what the wallet is doing. Regarding indexing, the way to solve this is by explicitly tagging each of these outputs, each of these mints, certificates, or whatever, with an ID or an ID pattern. You can even design a pattern based on the actual index order, of the outputs, for example, that you are defining. In this case, we just tag it as locked output. So then the withdrawal transaction, or the unlocking transaction, the transaction that will be executing this validation, will need the exact UTXO to rule, right? To apply the logic of allowing this input to be consumed or not. Which input? The tagged one. And how does this second transaction is able to find this exact index, outputting the index? Well, it does it by referencing, I don't know if you're watching here, it does it by referencing the locked output, the tag that you mentioned or instructed on the first transaction. But how? Like accessing the results of the build transaction function, accessing an object inside these responses, this result, that is called index map. On the index map, you dive into the output section of this index map. Also, you have means, you have certs, certificates, rewards. Here is the exact keyword you used or you produced with the ID pattern thing, the ID pattern function. Here's where we have the index of the input. And here, of course, the transaction hash. Well, we just get the transaction hash of the first function. This is ideal because we are building the two transactions on the same script. In your case, this will be split and you will be dealing with part of this information passing through the DApp itself. The DApp will have to keep some track of this stuff. But to allow you to keep track of this stuff is the index map feature that will allow you to tag and retrieve the right index that you will be then using. For example, this also will help you, will avoid prevent you having to go too much to APIs to check on the ledger itself to find the right values. You can try to use this information and will be okay. Never raise hands. Come on, just interrupt me.
No, I know. I it's because I wanted you to finish your statement. But yeah, I wanted to indicate I had a question specifically on this. First thing, the ID pattern. Is this the same thing, or this is GC specific, correct? This isn't within the contract. So this wouldn't be like the nonce that you provide in the datum, right? But it could be used in conjunction with it, potentially. Anyway.
Nonce. No, it really has nothing to do with a nonce, but if you parameterize a smart contract using these values, for example, that resembles like a nonce because it will change the final object you are trying to produce. But no, the thing is
right,
that you can use this. You can use this even. You can. It depends on how you design your smart contract. This ID pattern only solves you one problem. Like, you give GC the task of building a transaction, but you need to know, for example, the exact output you have tagged, the exact output you're designing. Which index will be? Because remember, GC will optimize outputs, will create change outputs for you. Maybe this transaction will be consuming other inputs as well, will be having other outputs as well. So which output is the right for you? Yeah.
The ID pattern, I think it specifically mentions about collisions, right? Because you don't want, I don't think it will allow for collisions anyway, but what this is tagging is the actual UTXO, right? So this is all about, like you're saying, how does GC build this transaction? So it needs that exact UTXO, because otherwise GC wouldn't know how to build that transaction without querying block cross or the dandelion node to see which was the last UTXO use. So, okay, this is very much the UTXO tagging. So if we did not inject or utilize the ID pattern, we would have to then reference the UTXO at that point. We would have to know our exact UTXO. So you're essentially, I see, you're leaving the breadcrumb. Understood.
Exactly. Because also you have a lot of control on this DSL regarding the extra regarding extra information that is being coming as a result of each of the functions you're running. One of these extra information is, for example, this index map. And exactly what you said, exactly. Like, imagine we have two outputs, one that goes to the smart contract, and maybe other that goes to elsewhere, right? To other address. But we use the same. This will be a problem because there will be a collision. Most likely because of the ordering, this one will take precedence. And this will be a conflict. Here is where this is an ID pattern. Every time you read pattern on GCScript means that there are chances for you to automate the creation of this based on, for example, the order on where the items are being placed, or under the what property name are being placed on the JSON. On this script. So, for example, if right now I put, I have problems with this keyword. Sorry. If I put something like this here, and maybe also there, here, the thing is that key or index, also we can be using the index keyword here. This will be the item with index 0 on your outputs definitions. This will be the 1. And if you use key or index, for example, this will be replaced by that, right? So here is how you automate creating, proper tags. But just mentioning this because these are things that are on the documentation, but are very tricky if you don't really dive into it or watch an example on that. So last thing, let's go quickly to the second transaction so we can jump into the details you want. So here, let me know if there is too much noise, because there is some noise here where I'm living. Okay, so on the witnesses part of the transaction, we pass a Bluetooth script, which is referenced. You need to pass the script X, right? From the produced validator, the language, which also is part of the response of that function, right? And the results of that function, you can just pass this. And this is important. You will be using a plugin. These are like plugins that this means some. This has some meanings depending on the plugin you're using, but in this case, will be the less assets, the less ADA. Let's say this is like it means that, but basically this will give you the best coin selection input to be used as collateral, right? For this transaction, for the Bluetooth validator. Basically, that's what you need. That's all. That's everything you need. So let's jump quickly into the code here, and then let's jump into yours. But bear with me. Here, the reason why we pass the code, the source code of the smart contract, but we pass it encoded in X or in base 64 maybe would be better. The reason is because this is JSON. This language, this DSL is pure JSON. It has to comply with JSON. If you just pass a string here with some, sorry, it's not only JSON. It's meant for the web. If you pass something that it's not JSON exactly, of course, that's a problem. And if you pass a string with certain HTML elements that may be used to try to cause some damage on the wallet itself, or maybe any other DApp dealing with this data, there are filters that filters this, for example, HTML attacks or stuff like that, to prevent cross-scripting attacks, for example, and other problems. So yeah, basically this is why we pass source code encoded. Some people said to me once, no, you're passing the compiled Bluetooth script. No, this is source code. And what we are going to be doing now is to decode this and analyze it. So also an important thing is that we are using this replace all function, ISL function, to parameterize this smart contract. So we are literally looking at the source code for strings that match certain patterns and replacing those to the actual values we want to inject. Okay? That's how you parameterize smart contracts. It's quite easy. I mean, basic. It's not something super complicated. So ASCII X ASCII, what is it? I think this will work. Oh, yes, but very ugly. Let me see if there is another. Are you with me?
Yes, sir.
Okay. Yeah, this is better. So here I'm just pasting.
Yeah,
I'm just pasting the inlined encoded contract code, and we are literally reading the contract, right? What I'm going to do for syntax highlighting, and this is good, this is where Inception is good, the IDE that Martin created. But I will go step by step, and then I will let him to introduce the tool for for doing the same thing, but a bit more comfortable than this. So let me see. There was okay. This is the playground, the Ilias playground, where you can just code and compile some Ilias code. So literally, this source code has even comments. So this is nice. Like you are creating a GCScript that even has commented, smart contract code. Check this out. This is the structure, right? This is the structure this is the definition of the structure that goes in the datums that this validator receives or is expecting. You have a number, right? And you have a key hash for the owner and a key hash for the beneficiary. If I jump into the code, I can see the exact same thing here. I have a number that actually this number is a slot number, and these bytes are from the owner and these are from the beneficiary. This is a one-to-one mapping of Ilios code of an advertisement. A one-to-one mapping of the Ilios code. Sorry, what I'm doing. Ilios code here to the GCScript, let's say, version of this. That just in cases you need to know is the exact same way the Cardano serialization lib deals with this kind of Bluetooth data. Okay. What are you sharing?
Please continue. This is just, I'm prepping for later. This is the contract I was playing with, but please continue.
Perfect. Yeah, get it. Okay. So basically, I'm not going to dive too deep into this, but basically it's checked that if the transaction is signed by the beneficiary, I mean, it starts here. If it's signed by the owner, it will be validated as okay. Or if it's not signed by the owner, but is signed by the beneficiary after the locking time, a time lock, it will also be okay, will be validated. Everything else, this validator will respond with a false, and that will invalidate the whole transaction. Basically, these are Cardano smart contracts, are just validators, for those who don't know. And this is the nice thing, Gabriel. this is the nice thing about this system, is that you can create an example data based on this structure. See how we created this exact example datum constant that is of type datum, the type we defined here, right? And here we have some practical values for this. An example time, which actually should be a number, but it's a string, y. And then this other stuff. Reasons for these are that, let me check. In the code, if I will be breaking here this ISL just for analyzing what's going on. Let me see here. Okay, so this replace all function, right, is dealing with the source code. Here we have an X to string to UTF-8 actually function that decodes the source code. So here on this line we are just dealing with the smart contract source code as a string. So this function is just, as I told you, replacing pieces of that. In this case, we are looking for this needle, right, on this haystack, and we'll be replacing that for this number, which is actually making the code valid. So the example time string will be replaced, of course, by the number that I put on the code. Basically, putting here this on, on the fly when you're executing the GCScript and making this source code valid. Otherwise, it won't compile. This is how you can parameterize these smart contracts. Actually, the idea is to just introduce some values here, for example, on the logic or on some constants that you will be using. But what I want to go with this for you is that you can create an example datum redeemer or whatever structure you're dealing with, like this, like I did here, and with the exact name here, you can go. Remember, you can place it here, the name of these constants or these values, and this will export those values on GCScript. So then you will be able to check how these values are being built or should be built, right? Just an example. Okay, I won't be talking more. Let's jump into the code you shared. Or let me know what you want.
Does Martin want to demonstrate Inception?
I can do that. Yeah.
Okay. Can I very quickly open this here?
I'm trying to get the. Oh, did it do it?
Hey, it's not opening, probably. Not sure why. Maybe if you can share the code.
Yeah, I'll share the code itself.
Okay.
That's weird. I guess their share doesn't work.
Maybe it works locally.
Yeah, maybe just local.
Not much sense.
Right. So cookie, great. What I had before.
So I suggest you to do that. Oh,
okay, yeah, that looks like it. Let me paste the whole thing.
Okay, I think it will work. And also, Oh, but there are some weird characters. There is some encoding issue. Maybe you can share it on Discord, and I will copy paste. Also, you have been coding all this stuff without checking step by step.
Yeah, I mean, I don't have like, see, if I had Inception before, I would have done that. But yeah, like I'm following guides and like deploying the contract and being like, okay, it compiled, and that's probably right. So that's kind of where I'm like, Inception. Let me see what I missed.
Dude, you know what you need to do? Install Dandelion in testnet mode. You can very easily run all this stuff without syncing the whole blockchain, and you can change and you can start over with a clean slate. Every 20 seconds, you can just delete everything and run smart contracts. You can even make a script with a GameChanger pointing to your local system. You can even use their GameChanger to instruct with JSON to build like the structure you want, because you want to have maybe some UTXOs. You can do that in one script, and then you can just experiment and see exactly what is changing without seeing the whole blockchain.
That's nice.
But what if I want to DDoS the entire blockchain with terrible blockchain code?
I'm sure your Threadripper is more than capable of doing that, and you're welcome to do it.
I don't have the funds to try.
Hey, Gabe, did you share me the code?
Too busy joking around.
No, I'm not pushing anything. I'm just asking because maybe I was distracted. Sorry.
I haven't yet. No, I was, yeah.
Also, I don't know if you want to share it. Come on. You want? Yes.
I mean, at this point, I'm I'm not very confident about it.
You have to say this to us. Okay, let's jump into Inception. But you have all the tooling. You have like an overview of how you can just jump into the thing. Some tricks on how to export pieces of data and then reuse them. Martin, do you want to take from here?
Yes.
Okay, I will stop sharing. Let me see. Did I stop sharing? Yes.
Inception, guys. Oh man, this is a cool project. I also don't have time for it, but I will use it maybe. Yeah, in 2 weeks I have to do some presentation, and I'm building something like what you are doing, Sudo. And I'm running already a week behind and having all kinds of other cool projects to do. But Inception is like a tool which I would like to improve, like so much, because it can be so much easier. I've muted Ratio again because his wind is causing issues.
Dude, I don't even know how I came unmuted. I haven't even touched the microphone.
It's a mystery. That's doesn't matter, but I can fix it because I'm a moderator. Yeah, like we built this IDE because I also wanted to learn smart contracts, but to split up and be more realistic about how you are building a DApp. So the workflow is like you would expect, because right now in GameChanger, the script does it all in one go, and it's building contracts and then locking and unlocking. But that's not the reality, because somebody is locking it, somebody else is unlocking it. So, Adriano doesn't agree.
Yes, of course I'm not, because remember, those are examples, but of course a real application will be splitting stuff. I also mentioned this 3 times
Yeah,
ago.
no,
But
but
you're right. The
this
nice
is
thing about
there's
Inception
nothing
is that,
wrong with your examples. It's just that Game Changer doesn't allow to do it yet.
okay, I'm not competing. I'm just saying that the nice thing about Inception is that allows you to modularize the creation of GCScript and other pieces like datums and stuff. Of course, the IDE on the wallet, yeah, it's more basic tool just for solving the basic stuff.
I was not trying to, be critical at all. It's just a different tool. So yeah, just like with here, you can actually uh, insert your Helios contract and your datum and your redeemer, which are identical in this case, and you have tabs as well. And here you have like the first piece is create a contract, and it's actually taking this information here somewhere, like yeah, it's using this function to import the contract and then create the string from the contract you are actually defining here. So this means you could do that inside your dapp. So you could have the real string in your dapp and then run it. How I'm we have this IDE thing. I can't remember how that exactly worked. Do you still know, Adriano?
Yes, I remember we worked on this because
Yeah.
the magic to make this modular thing work is like adding like a pre compilation magic to merge pieces of code and to reorganize code. But the way we did it was I suggested Martin to make it in a way that is kind of seamless or very compatible with the GCScript syntax itself, not adding too much changes. So the only thing that changed almost or mostly is the URIs of those functions like import as data and import as script. So if we just change the URI there, instead of using, for example, GCFS, like pulling a piece of data or a piece of script from the on-chain file system, for example, or from X, like embedded as using hexadecimal encoding, one another URI possible was IDE, is pulling it from the same IDE, right? In this case, Inception. That was the idea. Yeah, that's how it works. Yeah.
So yeah, I would have to read the source code to really understand how you have to organize that. But basically, you can import the contract from here, and you can check out the source code from Inception because it's on my GitHub. And then basically, Inception is a dapp, which is a code editor dapp, but you could overlay your own application on top of it because the infrastructure is there to do it, and you don't have to make it look like a code editor. So yeah, we made some stuff which doesn't work very great yet, but yeah, just to add more examples, and yeah, the search capability doesn't work that great. I think we have just 2 examples, and adding more examples is also not that easy. But like you can add your own files. I have to look how that worked again. Man. Oh, here. Is that? No, that's duplicating it. Oh, I hope I didn't break that. It's like a long time ago I did this.
No, I think you're right. You need to clone it. There is a way to clone a file. I think you cloned a file or something like that,
Oh, like this. Yeah, that's how.
and then you customize it. I think that was the way, but I don't
It's
remember.
guys. It's weird. A lot of stuff is not good UI yet, and yeah, uh, I just made it what was at the moment the easiest. So it would be better if we had more time to make it better, but yeah, we didn't.
The truth is that it's a lot for such a few a small team. This is a great project, and yeah, I think Martin tried like twice to be funded on Catalyst, and it
Yeah.
was not funded. So I mean, come on, it's very useful. Would be great to have it. So please, Martin, keep trying on Catalyst. Come on, please, don't give up. It's a very nice tool.
Maybe we now have the groundswell of interest to make that happen. Let's see for when the time is right to do it. But as you can see here, this will import this contract, and already it's like a hex string, so it's safe to transport. It can, like Adrian just displayed before, it will just create all that stuff, and we use here the GameChanger to build this contract. So this contract will be returned as contract data. Continue.
So is it not possible to use direct Plutus code? We have to do it in that
No, you can.
We can still do the straight compiled Plutus code, correct? Okay.
Yeah, it's just that's the way. If you're a purist or if you're developing, it's nice to know that this is possible. That you can just it's like building from source for smart contracts. So
no, yeah, I like it. I prefer it that way. I was compiling the Plutus first, and then like I said, there's just so many things that I don't know where the issue is, and at least here it's kind of like at least eliminating some of the variables.
If I would sell a house with somebody, you would have to have like a notary. I don't know. We have a notary servers in Netherlands, which makes the transfer easy because they're insured. So you transfer at the same time. But if you start doing that with smart contracts, you would have somebody who is knowledgeable about smart contracts. So he can check your smart contract. Like maybe you do even bigger transactions in the millions. You want to first build your contract and check this is the same address, because otherwise you will lose your cash, maybe.
Right.
So here we can see the exports, and you can see it generated this address with all the other data you would need. So you return, and you can see that also Inception received this data, and data will end up in this contract data.json. So the following script will also use the same function to use the data.json and all the other scripts you need. So the contract data you just generated. I think you can delete this one, and it will be created once you do the round trip. But yeah, I'm not sure. I will have to check it. But like
Martin?
Yeah.
I think maybe the new ones are going to the date. I mean, are those the ones that are prefixed with data and the date. So the last version of that payload, response payload, is the last entry you have on the file explorer. The data.
Oh yeah, it's good. Yeah, it ended up here. Yeah.
Yep.
So yeah, you would have to copy this stuff and then put it in the contract.
Yep.
Yeah.
I think that's a nice thing about this, that it helps you create these intermediate artifacts or design the data using the same code, the same even code base of your project, and then you can deal with those constants and whatever and customize those. You can do the same with the other IDE, but here the nice thing is that it creates this story. I mean, it's create like a file story, right? And you have different versions of the responses, and you can just reuse the data. It's very nice.
But yeah, you can see that I made this maybe more than a year ago, and I can't remember really how we did it. So I know certain aspects of it, but I don't know the details anymore. But you can see I don't need to, because I just have to I just have to press play on 1, 2, and 3, and it works. And then
So in this case, sorry to interrupt, the data that you have here, this JSON file, is only a reference that is used to build the GCScript, correct? Like this is kind of like storage that's kind of, think about it like cache in a sense, maybe from the IDE. That's it. Yeah, it's essentially this is what's you. This isn't like a struct. This isn't the datum or anything. These are data points that GCScript needs, or that GC needs to build the script, right? That's kind of like in a sense, like cache storage.
It's like the same thing that when you run a script on GC, I mean on the IDE on the wallet, that the results are stored on this local storage place. Local storage, at least on that tab, on that moment, is being stored there. But the last results of your script, in this case, this feature that Martin was showing, allows you to retrieve more than just one, like the last version.
Right.
You will be able to capture all the responses of all the executions of the GC scripts you're launching. Then
Right.
you can compare, you can reuse that produced data, all those files. That's how it works. You can, because our automatic